Hey everyone, welcome to your Play Posit for the week. Things look a little different than usual. You can see we're missing my usual welcome screen. I did this on purpose. What I'm going to do is basically finish the notes from our live class so you guys can check your work against those practice problems we were doing. This is also going to be for my students who, I think I told everyone this, but I lost power this morning in the middle of one of my sessions. So thankfully the power was returned quickly, not quick enough for us to continue with class, but this will get you the information you need from our missed session as well. So we are covering composite figures, and you guys all told me in class that composite figures are shapes that are made up of two or more items or shapes. And I pulled this example of my composite figure in the real world. You can see we have lots of triangles, some squares, some circles, some rectangles. What do you call this shape? I don't know. Maybe this is a like an oval or an ellipse. Got some spirals going on here, rectangles, even squares here at the bottom. So lots of shapes coming together to compose this entire structure. This is an example of some composite figures in the real world. All right, so we're going to look at this polygon and determine the perimeter. Remember, perimeter is the distance all the way around the edge. So we're going to need all the measurements from every single edge of this shape. So we're going to use all the clues we can to try to fill those in. So if this is 16, we know this is 16, right? And then let's see, if this is 20 and this is 16, the whole thing is 20 plus 16. So this whole thing is 36. And so that would make this 36, right? And the last thing to get is this length right here. Well, if the whole thing is 57, and we know these two pieces are 15, all we have to do is take out 15 and 15 and see what's left. So that would be 57 minus 30, right? That is 27. There we go. Now we have all the lengths of the shape and we can just add them together. 15 plus 16 plus 27. I'm just adding up all the edges, which you should totally take your Desmos calculator and do that. And when you do that, I only remember this because we got to this one in my second class. In our second class, it is B, 218 centimeters. So one tip is to go ahead and use the clues within the problem to fill in all the side lengths that are missing. Let's just confirm that. For some reason, I'm thinking it's A now. So we are not going to have another moment of Play Posit errors, are we? I'm going to be careful, take my time, go use my Desmos. Let's do it. So 15 plus 16 plus 57, 15 plus 36 plus 27 plus 36, 218. Okay, good deal. Here's our next one. Here's our composite shape. We have a rectangle and a triangle, and it wants the area. So once you've determined your shapes, you want to grab the formula for each of those shapes from your formula sheet. So area of a rectangle is length times width, and area of a triangle is 1/2 times the base times the height. Once you have your formulas picked, we're just going to plug in the numbers. So here's the rectangle, right? The length is 15 and the width is 12. Let's do that. 15 times 12, 27. And then over here, we're going to have 1/2. The base is 7 and the height is 12. So 7 times 12 times 1/2. 7 times 12. I might just do 0.5. That's the same, right? It's easier to do it. Otherwise, you would go like this. There we go. 42. And Now, what's the total area? So all you do is take 42 and add it to 27. 69 centimeters squared. Remember, area is always squared. And that's because from the formulas, if we plugged in the units, it'd be 15 centimeters times 12 centimeters, right? And centimeters times centimeters gives you centimeters squared because 1 plus 1 is 2. Remember that from algebra? X times x is x squared because 1 plus 1 is 2. When you multiply, you add the variables. That's why we have squared for area. It's also why we have cubed for volume. Like length times width times height. See how there are 3 variables? So that's why it's cubed. I wonder if you ever knew that. All right, find the area of this shape. Now, the composite figures might not be as clear in this one because they didn't give us those clear boundaries, but you can certainly draw your own. Right? We see a rectangle and a triangle. So first they're telling us this whole thing is 180. Well, if this piece is 180 and to here is 110, to find this piece, we would just subtract, right? 180 minus 110, and that's 70. So the two parts added together give you the whole thing. We're using the segment addition postulate there that we learned. We're going to use the segment addition postulate here as well because the whole thing is 140. This piece is 50. So to find the rest, we're just going to do 140 minus 50. That is 90. All right, I think we have everything now. We have it's kind of similar to the last one now, right? The area of the rectangle is 110 times 140. Careful there, don't take the 180. 180 is the base of the whole thing. We just want the base of the rectangle. And then area of the triangle is 1/2 times the base of just the triangle times the height of just the triangle times 90. All right, let's go to our calculator. 110 times 140. 15,400. That's huge. I guess because it is centimeters, so it's not that big. All right, and then 70 times 90 times 1/2. 3150. And then we'll add it together, right? $18,550. That seems really big. I wonder, I'm curious how many inches that is. Centimeters just don't like process in my head as well, you know? How many centimeters in an inch? I don't even know. You guys know? 1 inch is, oh, okay. 1 inch is 2.54 centimeters. So it's not as big as I thought. We would divide that by 2.54. Still pretty big. 7,000 inches? Holy bananas. Crazy. Interesting. Let's just double check our math here, right? So 110 centimeters times 140. Okay. And then 70 times 90. Okay. Looks okay. Here's a problem that you guys will likely see on a test this year if you haven't already. And it is something that we see often in the real world. I know I keep saying that, but it's true. You'll come across this where you're trying to find more of a I don't want to say challenging, but just a more realistic area. You know, you're not just going to have like, oh, find this square. So I think of this when we were building our house this year, we got to pick out the countertops, which was crazy, like stressful, but also fun. And I remember talking to the sales rep about our sink. And of course, my math brain just started working, and I was like, "Oh, well, what's the area of the sink? You know, how much countertop are we losing here?" Because there, you could even think of this image as my countertop, and this is our sink. So it was kind of fun to talk through that. So this is definitely realistic. The other thing I want to just point out to you guys are the units. Make sure you're just confirming that in the image, all the units are the same. If they're not, we just need to convert them so they are. So we kind of have two options here. I want to find the area of the shaded region. My brain says, okay, let's find the area of the whole thing, because that's a rectangle. And then we can subtract the area of the circle. So area of the rectangle is length times width. So that's going to be 18 times 12. And now a new one we haven't done yet. Area of a circle is, I want to show this one to you because we haven't done it yet. Where did it go? Here it is. Oh, the reason I wanted to show you the circle is because they give you two options for the circumference. And that's just because they have it in terms of r for the radius, 2 times the radius, or using the diameter. Remember, the diameter is 2 times the radius. So they're the same thing. So area of a circle is pi r squared. I have a joke for that. Are you ready? We say pi r squared. No, pi r round. Oh, is that funny? They're not square. Pi r squared. Squared. Nope, they're round. Oh, that's the formula. Okay, pi r squared. So I briefly touched on this in one of our previous play posits, but unless it's told to you, you can either use the pi button or you can use the pi approximation of 3.14. Sometimes you'll leave the answer in terms of pi. It just depends on what the problem is asking for, what information it gives you, and what the answer choices are. So if they're multiple choice and all of the answers have pi written like this, like, 5 pi, then you're going to leave pi in the answer. So let's do the radius is 4, right? So 18 times 12, 216. And then we're going to have 16 pi. Let's do it. 16 pi. I wrote the word pi and pi popped in. So what happens is when you do that, you're going to start to round. And that's why usually the problem will tell you, oh, use 3.14 or just keep pi. So for now, let's just keep pi because it wants us to find the area of the shaded region. So we're going to take the whole entire area, that's 216, and subtract out the sink, 16 pi. So let's see what that is. 216 minus 16 pi. Now let's go ahead and round because we have our final answer. So 165.7 centimeters squared. That's how much they're going to charge me for my granite countertop. They're going to subtract out the part that I'm not going to get. Here's another one. Find the area of the shaded region. So we want to find the area of the whole circle, whole big circle, and then we'll find the area of these two little circles and subtract them out. All right, so let's fill in what we know. Actually, first, we know we're going to find the area of these circles, right? So area of a circle is pi r squared. So we could do this first larger one here with a 3, radius of 3. So that would be 9 pi. And then the smaller one with a radius of 2, that would be 4 pi. And then we have to find the area of the large circle. And I don't know about you, but just looking at it, it's like, well, what's the radius? I know I need the radius, and we don't really know what it is quite yet, right? Because we don't really know where the center is. But could we use the numbers that are given to figure this out? So if this is 2, then we know this must be 2. Remember, the radii are the same distance all the way around the circle. And if this is 3, then this must be 3. Now we know the diameter of the large circle, right? We know these are diameters because they're going through the center. So this would be 6 and 4, right? So the entire diameter is 10. If the diameter is 10, what's the radius? The radius would be 5. So we can find the area of the largest circle, and it is pi 5 squared, which is 25 pi. So now we're going to take the entire circle and subtract out the other 2. So let's go to our Desmos. 25, 9, and 4. So 25 pi minus, make sure to put this in parentheses if you're going to do it like this. You can do each number individually and then add them all together. I just did it like this. So we'll say 37.7. And this one does not have any units, so we'll just say units squared. Here we go. Here's another one. Find the area of the shaded region. So we're going to be able to split this up into composite shapes. So I see 3 that we're going to need. We're going to need to get this rectangle here, this rectangle, and then this square. So the area, let's try to fill in some things that we don't know. Let's see. So these are all 2, right? And this is 3. So if this is 3, that makes this 2, right? Because 3 plus 2 is 5. I don't know if I'm going to need that. I'm just kind of like, that's where my brain is going. We do need like this little piece here. And also this piece. Let's see, if this is 7, then, and this is 10, then this must be 3, right? Wait, yeah, this is 3. Yeah. And this is 7. So this is not labeled that great. Well, it's fine because it's the whole length here. So 10, this whole thing is 10 and this is 7, so that makes this part 3 because that would make this whole thing 10. See that? Okay. Oh, this is actually not as bad as I thought. This is 3, just like this. Okay. I think we can do it now. So the area of this first rectangle is going to be 7 times 3. So that's 21. I might just write it in there. The area of the box is going to be 2 times 2, right? That's 4. And then we need the area of this whole shape. 3 times 5, that's 15. So we really only need to take out this white square. So I don't know why I keep going back to my kitchen. Kind of think of this as an island. And maybe this is the area for your dishwasher, although you usually have the same countertop. But maybe they need to know the area under the countertop to include your dishwasher. That'd be not a great place for that. Never mind, because you couldn't open the door. Maybe this is something else, like a wet bar or a sink, a square-shaped sink, like a farmhouse sink. Yeah. So the whole thing is 15, but we need to take out the 4, right? So the area we're going to include over here is 15 minus 4. That's 11. And we'll add back in the 21. 32. That one was tricky. All right, last but not least, find the area of the shaded region. I'm seeing lots of right angles, so that should tip us off, right? We definitely have squares and we have right triangles. So we might be using the Pythagorean theorem when you have a right triangle. So let's see what we can do. We know that the sides of the big square are 6, right? 2 plus 4 is 6. So these are all 6. So that's good. We can find the area of the big one, and then we just need to subtract out this square. So let's, oh, look, you guys, this is a right triangle. There's our hypotenuse. We can use Pythagorean theorem. 4 squared plus 2 squared equals, we don't know, squared. We can call it C if you want. So 4 plus 16 equals C squared. 20 equals C squared. And then remember, we just take the square root of both sides. I'll leave it as a radical just because we know this is not a perfect square. You do always get 2 answers when you take the square root, but like we've talked about, we're only going to take the positive solution when we're talking about length. So the length of this hypotenuse is root 20. It's totally fine to leave it like that. I promise. If you wanted to get a decimal, you could, but then you're going to end up, rounding. Look, square root of 20. See, you're going to lose all these really good decimals if we round. So let's wait to round until the very end, if necessary. All right, now we know this square is root 20 by root 20. So the area of the big one is 6 by 6. That's 36. And the area of the inside square is root 20. Ooh, this is fun, times root 20. Do you remember what happens when you do root 20 times root 20? The radicals disappear. Like, check it out. If we did root 4 times root 4. Root 4 is 2. Root 4 is 2. You just get 4. Let's see. Root 20. Oops. Times root 20. And I'll show you what happens. Whoopsies. Hey, guys. Go back there. See, you just get 20. It works that way with any number. Look, root 16 times root 16. Oh, it's 16. Root 243 times root 243. What are we going to get? 243. Yep. It's pretty special. Those radicals basically cancel. So you get 20. Okay, so the big square is 36. The small square is 20. So we're just going to subtract it out. And you get 16. There we go. So these 2 different kinds of problems, you want to use the clues within the problems to fill in the missing side lengths. And then these kind, you want to subtract out the area from the larger shape. So I hope that this was helpful. I hope you guys were able to practice these on your own before you came to the Play Pause It. If not, you're pausing this as you went. Please reach out to me if you guys need any help. I want to just take you on a quick OMHS calendar tour because the rest of this week, I think today, Thursday, you guys have just 1 item left this week. Yep, volumes of prisms and cylinders. And then tomorrow, Friday, the only new thing you're going to have is your class connect attendance quiz. I know usually on Fridays, yeah, the last 2 Fridays, you've had new lessons. This Friday, you don't. So you could certainly take it as a catch-up day in math if you want to work ahead, or maybe you need some catch-up time in another subject. But the only thing you'll have for Friday for math is our Class Connect attendance quiz. And then next week, all of these things are kind of very similar. You're just practicing volume with pyramids and cylinders and different shapes, cones, and different ways that they word the problem. The only time it gets a little bit different here is on Wednesday on 2.10 when we talk about changing the volume using like a scale factor or the ratio. And we'll talk about this in live class on Wednesday. So we are still kind of ahead, right on track. And then we're going to be getting into, these are like just more word problems. You'll take your test and then we go to circles. You guys, circles is so much fun. It's It's just going to be a lot of fun. And then we just have trig and then we're done. I just can't even believe it. So again, please reach out if you need anything. I'm here for you and I'll see you next week. Bye, everybody.